So when we introduced imaginary numbers, we said, it's something that helps us evaluate this square root. We say that this is 4i, right? Because you can't find a real number that multiplies by itself to equal -16. But we have a definition. We have that I equals the square root of -1. And so using that definition, if you square both sides, you get I squared equals -1. So that might help you out of jams with some calculations that you make down the road. So to rewrite something in terms of I, if you have negative square root of 15, all you have to do is say square root of 15 and I, because it's like we factored out a square root of -1, right? This is the same thing as this. So we can rewrite it as two separate square roots, and then that's, oh, sorry, -1. That doesn't make any sense yet. Times -1, right? 15 times -1, that's the same thing as -15. So you can factor out that I that way. Sorry, that at the beginning that didn't make much sense, did it? Okay, so if you have to write something in terms of a plus bi, this is like standard form for a complex number, okay? For like a number with imaginary parts. So if we have -6 minus the square root of -36, we can first evaluate this. The square root of 36 we know is 6. So the square root of -36 is -6i. And look, that's a, that's your b, and that's your I. It's already in that form. But if we have something like this, then distribute that negative sign, and we can drop the parentheses here because there's no sign, no number in front of the parentheses. Distribute that negative sign, make sure you're minusing both the 7 and the 8i. And now subtract the real numbers. 6 subtracted by 7 makes -1. And -9i subtracted by 8i makes -17i. So there, it's in standard form, A and B.